friends, welcome back to my YouTube channel MS Maths. इस वीडियो में Hello friends, welcome back to my YouTube channel MS Maths. In this video, we are going to discuss about the questions based on source and sink. So basically, the concept of the source and sink that we have already discussed. So basically, the source is a point from where fluid flow which is symmetrically radius is produced, and the sink is a point where the fluid flow is symmetrically radius inverting. Okay, so we'll discuss these both things here, and the combination of the source and sink is called the doublet. And earlierly in the previous videos we have we have derived the complex potential function for these both source and source sink and the doublet. In this particular video, we're going to discuss some example so that the concept will be more clear about the topics. Okay, let's start. Example number one is basically the find the stream and potential function. It means stream function and potential function for phi is equals to, sorry, W is equals to phi plus iota sine. So if we have, is equals to mu by Z. So we'll just find the what is the potential kind of what is the stream function, what is the potential function for this. If we have if we have phi plus iota psi is mu by Z, then the phi is equals to always minus of cos theta upon r, and psi is equals to minus mu sine theta upon r. This is the question related to the doublet, where mu is the strength, that is m into delta s. S is the distance of the strength and m is the strength. Okay, now here, if if we want to calculate the potential line, or potential line, yeah, not potential function here. Of course, we have to find the potential line and stream line for this. So if we want to calculate the potential line, so the potential line, then potential function will be the constant. Okay, so my mu cos of theta upon r, it should be the constant. So it is mu cos of theta is equals to c into r. Then what is this? What is this? This is basically the if we divide mu is here, then c by mu into r. I say that cos of theta, I say this is my c dash into r. Okay, whatever it is c dash into r. And what can I write? If I can write, if I will multiply r both side, then what is r cos theta is basically the x. Like basically, see one thing. If I can, if I write this thing is here, so cos of theta is my c1 of r. I say this is my c by mu is here, or this is cos of theta is equals to c1 into r. This whole thing will be will going to be a constant. So this is my line, or basically the potential line, in polar coordinate. If we want to convert it into the Cartesian coordinate, so we'll just multiply r both sides. So we'll get c1 r square, and this is what x is equals to c1 into what is r. R square is basically the x square plus y square. Okay, because of r is equals to, x is equals to r cos theta and y is equals to r sin theta. So the x square plus y square is basically r square only. Now, next thing, if we want, yeah, this is potential line. If we want to calculate the streamline, the psi is equals to constant. If psi is constant, then minus of mu sine theta, or basically, minus of mu sine theta by r is equals to c. So what is this? This is going to be sine theta is equals to some c1 into r, or it will basically r of cos theta is equals to some c1 into r square. Then it is y is equals to some b, or some c1. I say this is my some c1 into x square plus y square. This is what? This is the stream line here. So this is potential line, and this is the stream line. Now, the next question is very, very important. This is basically the what arrangement of source and sink give the function w is equals to log z minus a square by z and draw a rough sketch of the streamline. Prove that two of streamlines subdivide into the circle r is equals to a and axis of y. So these all things we will solve, will prove. So just so on solving this question, what is the complex potential function? That is log of z minus a square upon z. Now, so W is equals to, I can write, this is what, Z square minus A square upon Z, and by the logarithmic property, I can write it as log of Z square minus A square minus log of Z. And further, I can write it as log of Z square, or sorry, Z plus A, okay, and log of z plus a into z minus a minus log of z. And similarly, I can write here log of z plus a plus, because it is in multiplication with log, so this thing will happen. This is the expression of the this term. Now, what is the complex potential function due to source and complex potential function due to sink? Okay, the potential complex potential function due to source and sink. Complex potential function due to source, it is what, minus of m log of z. And so the same thing, complex potential due to sink, so it is what, m log of z. Now, if we compare, we'll just get, this is what, this is the complex potential, or basically the source at, or basically I say this is what, z minus a, and this is what, z minus a. If it is if it is z minus a, then it is nothing but the complex potential function at, this is what, the complex potential function at, see, just let me write it. It is what, the complex potential function at a comma 0, and this is what, at a comma 0. Now, if it is z minus 0, then what is this? This is the source at origin, because it is minus of log z minus 0. This is what, sink at a comma 0, and this is what, sink at minus a comma 0. Okay, so what will be the sketch, or what will be the like diaphragm for this? It is what, it is on a straight line, that is basically here, in such a way that this is sink and source. Yeah, this is your 0 comma 0, this is a comma 0, and this is minus a comma 0. So here it will be source, and here it is sink and sink. Okay, of strength 1. Okay, now next we'll show that the yeah, our question is basically, the streamline is basically, yeah, the streamline divides into a circle, r is equals to a. So now we'll just find the streamline. So how can we find the streamline? First of all, we have to get w is equals to phi plus iota sine. This is what, this is the stream function, this is the stream function, and this is the potential function. To get the potential line, we'll put this as constant. To get the streamline, we'll put this as a constant. First of all, we will get these things. So what is the, yeah, it is log z plus a, log z minus a. We'll just convert it into Cartesian coordinates so that we can find x plus iota y terms, or we can just separate it. So we have w is equals to log of z plus a plus log of z minus a minus log of z. So we can just write it as it is nothing but log of x plus a plus iota y, and log of x minus a plus iota y, and minus of x plus iota y. Okay. Now, what can I do here? There is a relation, basically, the relation of the complex analysis is basically says that if you have log of x plus iota y, then 1 by 2 log of x square plus y square plus iota tan inverse of plus iota tan inverse of y by iota tan inverse of y. This is the relation that we can write it into a real part and the imaginary part. Okay, so we'll just separate these things here. So my w is equals to log a plus b. So I will just apply this is what 1 by 2 log of x plus a whole square plus y square plus iota tan inverse y upon x minus, sorry, x plus a. Okay, next I will just put for minus for this term. So it is log of, yeah, 1 by 2 log of x minus a whole square plus y square plus iota tan inverse y upon x minus a, and for last it is minus 1 by 2 log of x square plus y square plus iota tan inverse y by x, because this is at origin. Now we'll just separate all the real part and imaginary part. So what we'll get? We'll get w is equals to 1 by 2 log of w is equals to 1 by 2 log of, so it is basically the w is equals to 1 by 2 log of x square plus y square plus a square minus 2ax. Okay, we have taken the 1 by 2 whole common here, and wait, this is what 1 by 2 log of x square plus y square plus a square minus 2x plus log of x square. We have opened this squared also. Square term, then y square plus a square minus 2a, sorry, plus 2ax. Okay. Yeah, here is it is plus and here it is minus. So it is minus of 2ax. Next, minus log of what it is, x square plus y square. Yeah, it is simple, x square plus y square. So this is your imaginary part. So this whole thing is going to be pi plus iota. Next thing, tan inverse y upon x minus a plus tan inverse y by a, tan inverse y by x plus a, and minus of tan inverse. Yeah, it is minus here because the last term is minus. So the minus term is here. Then it is what? This is basically the y by x only. So this is what? This is going to be sine function. Wait, this is going to be sine function. Sorry, sine. So this is basically my stream function. So to find the streamline, we'll just put the stream function as constant. So what can I do here? Sine is equals to what? Tan inverse. What is this? This is tan inverse A plus tan inverse B plus tan inverse C. So what can I do? So I can just put tan inverse A plus tan inverse B formula here. So it is what? Tan inverse of y upon x minus a plus y upon x plus a divide by 1 minus, okay, yeah, it is 1 minus y upon x minus a into y upon x plus a minus tan inverse of y by x. Okay, so the sine is equals to tan inverse of, I can just find it is what? It is basically the 2 of x y divided by x square minus y square plus a square minus of tan inverse y by x. Again, I will put tan a minus tan inverse a minus tan inverse b. So it is what? I is equals to tan inverse whole. We'll just put it here. Then x square y plus y cube plus a square into y divided by x into x square plus y square minus a square. This is what? This is the stream line. It will put, yeah, this is the stream function, sorry, this is the simplified version of stream function. Now we'll find the streamline, then we'll put it as constant. So my psi is equals to c, so that y, yeah, just we can write it as psi for a streamline. You can write here for, sorry, for streamline we'll just put psi is equals to c here. So the tan inverse of x square y plus y cube plus a square y divided by x into x square plus y square minus of a square is equals to some constant c. So what is this? This is what we get: x square y plus y cube plus a square y. We'll put it as x square y square minus a square is equals to some constant, because tan c is again a constant c1. Now, if this thing, or I can write it as y into x square plus y square plus a square upon x into x square plus y square minus a square is equals to some c1. Okay, so if it is, yeah, we have that it is subdivide, or it is a circle r is equals to a and axis of y. So for axis of y, how can we see here? If my c1 is 0, see, if my c1 is equals to 0, then I can put c of x square plus y, sorry, y of x square plus y square into a square is equals to 0. It means y is equals to 0. What is this? X axis. If c1 is equals to 0, or basically we can write it is tending to infinite, what can I do? It means what? It is 1 by 0. So y of x square plus y square plus a square upon x square plus y square minus a square is 1 by 0. Then what is this? X square plus y square minus a square is equals to 0. This term will never go 0, so this is equals to 0. What? Y axis. So this is the case we have to prove. Now you can see, if it is 0, then x square plus y square is equals to a square. This is what? The circle of radius. This is what? The circle of radius a. Okay, this is at y-axis, circle of radius a. Now, what is the sketch? What is the rough sketch for this? The rough sketch for this is, can be, yeah, this, what are the position? This is what? Source, oh, sorry, the sink. We have earlierly showed that at a comma 0. This is what? The source 0 comma 0, and this is what? The sink at minus a comma 0. So it will be a circle, it will be in a circular form in such a way that from source to sink, in such a, like this family of circle is here. Okay. Along y-axis, family of circle. So this is the rough diagram of the stream lines, these types of the stream. These all are the stream lines. So this is all about this question. In this question, we have so many types of the concept. So this is all about the questions. So thanks for watching my video. Keep watching MS Maths. Thank you.